Welcome to this explainer. Look, if you are tackling the Cambridge IGCSE Mathematics exam, specifically the 0580 syllabus or any of the extended papers, you already know that geometry can sometimes feel like trying to break through an absolute brick wall of a defense. The examiners are setting up traps, and if you don't have a solid game plan, it's really easy to lose possession of those precious marks. Well, today, consider us your mathematical tacticians. We are going straight into the playbook to demystify the elegant geometry of circles. We're going way beyond just memorizing the core formulas for circumference and area. We are going to break down the tactics, the execution, and the exact strategies you need to outplay the examiner and score top marks. So, whether you are just refreshing your memory or you're deep in revision mode looking to master these concepts for an upcoming paper, we've got the exact strategies you need to win.
We have a really tight strategic roadmap for today's session. We are covering 1. The constant of pi, 2. Unrolling the circumference, 3. The rectangle trick, 4. Working backwards, 5. Exact versus approximate, and finally 6. Real-world applications.
Section 1. The constant of pi.
Okay, let's kick off with one of the most beautiful and fundamental facts in all of mathematics. Think about this. All circles, everywhere in the universe, are mathematically similar shapes. I mean, it doesn't matter if you are looking at a tiny coin in your pocket, the center circle of a football pitch, or the equator of a massive planet. Because they are mathematically similar, the ratio of their circumference, that total distance around the outside edge, to their diameter, the straight line distance right across the middle, never, ever changes. It is an absolute constant. It's the foundational rule of the game when it comes to circles.
And of course, this famous constant ratio is what we call pi. Now, because pi is an irrational number, its decimal places literally go on forever without ever settling into a repeating pattern. It's infinite. But obviously, you can't write an infinite number on your exam paper. So for practical calculations, especially within our standard mathematical frameworks, it is most commonly approximated to 3.14 when we round it to 3 significant figures. But as we'll see later in our strategy playbook, knowing when to use 3.14 and when to leave the symbol exactly as it is absolutely crucial for protecting your marks.
Section 2. Unrolling the circumference.
Let's look at how we actually build our offensive line here. If we start with our core definition, that the circumference divided by the diameter equals pi, we can use just a little bit of basic algebra to rearrange the whole thing. If you multiply both sides by the diameter, you get circumference equals pi times the diameter. Simple enough, right? But we know that a circle's diameter is exactly twice the length of its radius, so we can just substitute 2 times the radius right into our equation. And boom! This gives us the absolute classic, incredibly useful circumference formula. C equals 2 pi r. This is your primary tactic for finding the perimeter of any circular shape. Memorize it, but more importantly, understand where it comes from so you never second-guess yourself under exam pressure.
Section 3. The rectangle trick.
Now we're moving on to area. And honestly, this is one of my absolute favorite visual derivations in all of math. It's like a tactical formation shift. Imagine you take a circle, think of it like a pizza, and slice it into 4 equal pie-shaped sectors. If you take those slices and interlock them side by side, alternating one pointing up and the next pointing down, you get a somewhat wavy, weird-looking shape. But let's iterate. Slice it into 8 sectors, and it flattens out a bit more. The real magic happens as you just keep slicing. If you divide that circle into 32 equal sectors, or 100, or theoretically an infinite number of them, the assembled shape increasingly straightens out until those wavy bumps disappear entirely, and it perfectly, flawlessly resembles a straight-edged rectangle.
So why does this matter? Well, the crucial tactical point here is figuring out the dimensions of this new rectangle we've just built out of our circle slices. Think about where those edges came from. All those little curved edges making up the top and bottom of our new rectangle originally made up the entire outside circumference of the original circle, which we just proved is 2 pi r. That means just the top edge on its own, the width of our new rectangle, must be exactly half of that total, which simplifies perfectly to just pi times r. And what about the height of this rectangle? Well, look at the slices. The height is just the straight edge of one of those pie slices, which is exactly the circle's radius, r.
So, bringing it all together, we just used the most basic playbook formula for the area of a rectangle, width multiplied by height. By multiplying our new width, which is pi times r, by our height, which is r, we mathematically prove the legendary formula for the area of a circle. A equals pi r squared. It's such a beautiful, elegant way to visualize an abstract equation. You aren't just memorizing letters, you are reshaping geometry.
Before we continue to the next high-level strategy, subscribe to our YouTube channel, Ace the Exams, at acetheexams_CIGSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep moving.
Section 4. Working backwards.
Now, in applied mathematics, and especially in the Cambridge exams, the examiner isn't always just going to hand you the radius and ask for the area. That's too easy. That's a rookie play. Often, they throw a counterattack at you. They give you the total circumference or the total area first, and you have to work backwards to deduce the radius. Using algebra to isolate the radius on one side of the equation is an absolutely critical skill for top grades. If you know the circumference, you just rearrange your formula so that r equals c divided by 2 pi. Simple. But if you know the area, it's slightly trickier. You have to divide by pi and then deal with that squared term, so r equals the square root of the entire value of the area divided by pi. Mastering these inverse operations, knowing exactly how to flip the play, is essential for saving time on the clock and minimizing silly errors under pressure.
Section 5. Exact versus approximate answers.
All right, listen closely because this is where so many students drop the ball and give away easy marks. This is the penalty box of the math exam. Let me paint a picture of two types of students. One student rushes through the question, calculates everything perfectly, but then writes down a massive decimal and ignores the specific command words in the question. They lose the final mark. The other student, the strategist, reads the play perfectly. There is a crucial, undeniable difference here. If a problem specifically asks for the exact form, your final answer must keep the pi symbol, period. For example, writing 25 pi square centimeters. Why? Because pi goes on forever, so calculating it out into a decimal automatically, by definition, makes it an approximation. It is no longer exact. Now, if the problem asks for an approximation, or if it doesn't specify formatting at all, the standard Cambridge rule is to calculate the decimal using the pi button on your calculator and round your final answer to 3 significant figures. That would give you 78.5 square centimeters. Always, always pay attention to the phrasing of the question. It is literally the difference between an A and an A star. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries simply by understanding these exact tactical nuances. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back to the playbook.
Section 6. Real-world applications.
Let's put these formulas through a real-world stress test. Let's look at this highly practical rotating wheel problem. Examiners love this specific setup. It's a fantastic test of your conceptual understanding of what circumference actually represents physically out in the real world, rather than just being a line drawn on a flat piece of paper. When you see a question about a wheel, a bicycle tire, or a rolling cylinder, you need to instantly know the defensive structure you're up against. The absolute trick to solving this, the tactical breakthrough, is visualizing the wheel rolling along the pavement. When that wheel makes one complete physical rotation on the ground, the linear distance it travels perfectly exactly maps to one circumference length. The perimeter of the wheel is literally unrolling onto the ground. Knowing this, the execution is incredibly straightforward. We can just take the 25 centimeter outer radius given in the problem and plug it straight into our playbook formula. 2 times pi times our radius of 25 gives us an exact distance of 50 pi centimeters per single turn. Notice how I kept it in exact form there, 50 pi. If the question wanted it to 3 significant figures, you'd calculate it out, but leaving it exact during intermediate steps is a pro-level move to avoid rounding errors.
Okay, here is another classic, heavy-hitting geometrical challenge that shows up all the time. Calculating the total area of a composite shape. In this case, we have a somewhat elaborate garden made up of a rectangular center with round ends. When a student who hasn't prepared sees a weird, irregular shape like this, panic sets in. But for a strategist, it's just a matter of breaking down the formation.
You conquer composite shapes by refusing to be intimidated. You break them into manageable, familiar pieces that you already have the formulas for. Step 1. Execute the easy play. Find the rectangle's area by simply multiplying 16 by 8. Step 2 is where you outsmart the question. Instead of wasting time calculating 2 separate, identical semicircles and dealing with fractions, realize that they seamlessly combine to form one single full circle. Look at the dimensions. The width of the rectangle, which is 8 meters, serves perfectly as the diameter of this new combined circle. This means the radius you need to use is 4 meters. Calculate the area of that circle using pi r squared, and finally, just add the rectangle's area and the circle's area together to get your grand total. It's all about strategic deconstruction. Don't let a complex image trick you into forgetting your basic fundamentals.
We have covered a massive amount of tactical ground today, from the elegant derivation of our core formulas all the way up to conquering composite area word problems. You now have the playbook. But before we wrap up, I want to leave you with this somewhat provocative, higher-level thought. Mathematics gives us the exact, flawless formula for area by relying on the concept of an infinite number of perfectly straight slices. But in the physical, real world, where atoms take up actual physical space, and we absolutely cannot slice things infinitely, are any of our real-world circles ever truly flawlessly exact? Or is the physical world just one big approximation of our perfect math? It's a fascinating paradox to ponder as you continue your mathematical journey. Listen, students who actively implement these exact mathematics strategies we discussed today see an average improvement of 2 full grade boundaries. It's real and it works. But that transformation only happens if you practice consistently with our weekly videos and hold yourself accountable. So here is your final reminder. Subscribe to our YouTube channel, AC Exams at AC Exams IGCS, to excel in your Cambridge examinations. Subscribe right now to AC Exams IGCS and click that bell. Don't let another exam season pass you by wishing you had prepared better. Also, get involved. Drop a comment below right now with your specific target grade for mathematics and tell us the biggest challenge or most frustrating topic you are currently facing. Our team reads and responds to every single comment to help you out. Hit the like button, share this explainer with a study partner who needs a tactical upgrade, and keep practicing. Ace the exams. Your Cambridge success starts here. Keep exploring, and I will see you in the next strategy session.